Login acceptance.
Hello, everybody. It's exactly on time. Let's do the bit where I talk about things while people walk into the room. So first of all, I have a very long title for my presentation, Decoupling Springboot Microservices using workflow automation. I guess getting coffee quickly is the important part of this. I am Niall Deehan, that fine specimen on the left, and of course the more interesting character in that particular picture is Belinda Stoop. That is the greatest picture of me ever taken, and I will never not show that picture. So welcome along. I'm a developer advocate for Camunda, which is a workflow automation engine. It's an open source Java thing, and I'm going to just talk about how that's sort of some of the use cases I've seen with it, in particular, how people are using it to try to change how microservices work in order to make them way more reliable and way easier to decouple, specifically. So I'm going to start off with some slides, and mostly I'm going to be showing you a demo that I swear worked not too long ago. So first of all, let's talk about the classic thing that hopefully everybody knows, a little introduction into microservices that exist. Very simply, we have something like this. Maybe it's written in Spring Boot, maybe it's written in something else. It doesn't really matter, but the idea is it's a little independent thing that sits along, and maybe it has a friend somewhere else that is also independent and sits alone. At some stage, they need to have a chat about something, and in most cases, that means a REST call is sent from one service to the other, and then eventually we get a response. That's usually how these things work, and this is great because it has completely decoupled the two systems, and that has always worked. That is how you get started with microservices, is this decoupling and communication through public APIs and all those rules that we tend to follow. And this is how we get started. How we get into trouble is then when you have those two lovely services, and then you try to scale it, and then you try to add maybe a third. And that, of course, is reasonable, but things, of course, will get complicated when you have one service talking to a second service that subsequently has to ask the third service. This, of course, means that service number one actually doesn't know it's also waiting for stuff downstream. So we end up having to wait for a response from here, and subsequently, once we get that response, we have this. And there's a lot of problems with that sort of setup, and as you grow, you need a way to fix that. And there's actually lots of solutions for it. And I want to use coffee as a good example, because coffee is the perfect example, about why this is a good start and why it tends to fail. Generally speaking, this is a good example from where I live in Berlin, which is if I would go to get my coffee, I'd maybe order some cake and maybe a coffee. Then the cashier will take my money, and they will then go and they will say, they will go get my cake. Okay, then they will subsequently go to tell the barista, go make coffee. There's a queue forming behind me. This is very uncomfortable. I get very nervous very easily if I'm holding people up. Then eventually, the coffee brews. We're staring at it intently. It's coming any minute now. And eventually, it's okay, the coffee is ready. The barista can then say, good news, the coffee is ready. We then get back to the cashier, who then gives me my coffee. This, of course, is not exactly the best, most efficient way. It's called blocking. The nice thing about this is if you ask for something, you'll either get it or you won't. If anything goes wrong, it'll just completely, that's it. You keep your money and you don't get anything, which is a shame, but at least you still have the money. So the problem is the queuing mechanism that builds up. My anxiety around having people wait in order to get their coffee behind me is a bit of a problem that I would like to solve. And I want to actually show an example of this. I'm going to combine these two lovely aspects of coffee and microservice communication because I've created these three little services I'm going to demonstrate just now. One is a cashier, which is a little front end in which you can set an order. It then sends the order to an order sorter. They have the ability to get cake, and also they have the ability to ask the barista to make coffee. Okay, so then subsequently, if the coffee was ordered, it gets sent back to the order sorter, who gets the order together, and then we'll say, here you go to the cashier. Okay, so that's what we currently have. So let's take a look at that. Okay, so let's start this up. Here is my cashier. So I'm going to just start that up. Simple Spring Boot application that takes orders. My order sorter, which as I mentioned, is just going to take the order from the cashier and get cake or tell the barista to get stuff. That is my current setup. So let's see, they're all starting up. No problems yet. So let's go to my lovely front end. I'm not a front-end developer. So welcome to my first attempt. I found that you can use emojis recently, so that's a big find for me. So let's imagine that we would like some coffee. Specifically, Martha would like some coffee, so let's send that. Now, what's happening? We are waiting with the cashier. The cashier, of course, has told the barista we need coffee, and the barista is making the coffee. This is completely synchronous. Eventually, we come back, and the coffee is ready. Marvelous. We could also order cake as well. Why not? This is something the order sorter can get. So the order sorter you can see here gets the cake, then subsequently tells the barista to go make coffee. Okay, so that is the important stuff. There's not too much of interest going in with the code here. And as I change this dynamic, I'm only going to change one service. I'm only going to change the order sorter. The other two services, the cashier and the barista, will basically remain the same. Because if you look at the order sorter, and we will, the only important thing it does is it will get a request, which is some request that comes in from the cashier, and if it has cake in there, it'll go get cake, and it'll check if it also has coffee in there, it'll go tell the barista to do some stuff. So it can do either or. But it does them all synchronously, which means if our barista takes a nap, oh dear, and we want some cake or coffee, what's going to happen before it happens? Anyone guesses? Oh, too slow, it broke. Because even though potentially I could have gotten that cake, it doesn't matter because everything is synchronous. Either the thing works or it doesn't, and that's probably because if we didn't have that, we would open up a whole bunch of new problems. And I'm going to open up that whole bunch of new problems. So let's take a look what we're going to do. So I'm going to take some influence. We talked about that. There's a very famous Gregor Hoppe blog post that people should read, which is called Starbucks Does Not Do Two-Phase Commit. It is very, very interesting. It makes a lot of sense in the microservice world because, well, if we go back to this example, if you go to Starbucks, which I don't often, but if I were to, at an airport or something, I would go to the cashier, I would give them money, and they'd give me back nothing. Okay, which is weird. But they have told somebody else, here's the order to the order sorter, and the order sorter says, great, I'll take care of that, you take care of the next customer. Okay, and then you stand without money and without coffee for a little while, and what you're going into now is sort of eventual consistency, which is where we're going to have the order sorter will get cake if necessary, and they're also going to tell the barista, go make some coffee, and when you have it, give it to me, and they take care of that independently. So what I would like to do is change this completely synchronous system into one that is now asynchronous. That's the idea. The idea is my front end can now send some stuff, and we can show some of the benefits you get from that, and also some of the problems when you start doing that, because there are some problems to solve. So let's take a look at the first thing we'll do. Actually, do I have a slide for what I'll do? There is a slide for what I'll do. So I'll actually show the slide and then we'll do it. We're basically, as I said, going to change one thing quickly. We're going to add a dependency to this workflow engine, Camunda, to this particular little microservice. And that's all. That's how we're going to start. And what I want to do is slowly add more and more functionality, because it's usually a bad idea to make something go synchronously to asynchronously in one big bang. You might want to take some steps to see the benefits at each step of this. So the first thing I'm just going to do is we're going to leave it synchronous. We're going to add the engine, because the engine can be added and remain asynchronous, but it'll give us a bunch of stuff. It'll give us visualization, some history about what's happening, so we can just maybe baby steps into the benefits. So let's do it, and It'll come as no surprise that I have something prepared. So again, the code isn't too interesting. What I did was I added some dependencies, 2 dependencies in particular, one which is the engine and one which is the web apps, because I want to be able to look into what's going on in the engine. Now, a workflow engine, the point of it is to be able to orchestrate things that are happening. It can be done actually externally from the perspective of like a messaging system, something like an actual part of your architecture. It can also be embedded inside a microservice and just hold state for that microservice. But the idea of the engine is to be able to hold state and be able to deal with things that happen as the consequences of now adding state to your architecture. So what did I change? The only thing I changed from the previous thing we saw was I added this dependency. I added some settings here about the data source, so it's an in-memory H2 database. I added some Camunda settings, so I have a login and that sort of thing. It's not too important. And I also added a small change to the code, which is I commented out this. We no longer do this if statement, which was horrible. Instead, we replace it with this, which is just starting a process with the data. So we take it and we just start the process. Now, what does that mean, starting a process? It means I will run this lovely diagram. So I've taken the 2 services inside the microservice, so the sort cake, does this work? Yeah, sort cake order, and also the sort coffee order. I have an inclusive gateway, which means we can do either of them or both. And that's all. So just a little bit of refactoring here. But nothing should really change from the perspective of the end user. I'm going to wake back up my barista. Marvelous. And I'm going to do my other order sorter. OK. So now we have a little Camunda thing that shows up. And this will start up. And it doesn't do too much difference, as I said. So what still should happen is I haven't changed anything from the perspective of synchronous, asynchronous, but let's imagine Niall would like some coffee. Great. I'm still doing the same thing as before. The barista is still making the coffee. The difference is I can now look into the service. That order sorter service, I can now have the ability to log into it and click very irritating pop-ups away, and then go and check out my order, and there's the process that's running. And I can just check out what's happened. So you can see that I ordered some coffee, and you can see the route that it's taken this way. And I can also say maybe Pond would like coffee and cake. Great, let's send that. And as I said, this is still synchronous. We're still taking our time, but now we're actually going to probably see, once this thing returns, that we've now got an additional instance that's run through it. Yeah, there we go. So now we see that sort of thing. And that's pretty handy. We've changed nothing about our service, really, but we have some visualization. We also have some history view, which is also quite nice. And again, we don't need to hold state for any of that. We have not yet accomplished the important thing, which is, again, if our narcoleptic barista decides to fall asleep again, we then have that problem of, well, now everything's broken. It doesn't really matter. And that's the problem, the initial problem we want to solve. OK, so let's make some changes then. The next changes I'm going to make is actually almost entirely in the model. I already have the engine. I already have everything refactored to the point where all I need to change now is this. This is executable, which means that I don't really need to do too much more than add a few different things. The first thing I need to add is there's a little tick box here that says asynchronous before. That creates a transaction boundary. Really easy. So that means that as soon as the call is made, it'll return at that point back to the origin. So that the cashier will be told, once we get to that point before we execute it, we tell the cashier, OK, we got this, relax. And from that point on, we hold the state of the order, and we then will pick it back up and continue how we like to run it. Which means, because of that, we need to add a second service, a service that actually tells the cashier what happened. that it was a success. Because now that we have asynchronous communication, we can't rely on the transaction completing and then moving back to the cashier with some sort of successful call. So that's where we're at. So let's take a look at the result of that. I'll wake up our barista again, and I will try this lovely thing. Super. So again, the only change is the model. Now you can just deploy the model itself while it's running, and that would also work. But I just made it easier to demo by breaking it up into sections, and that you can easily follow if you like. It's all on GitHub if you want to play around with it afterwards. So that's up and running. I can then verify that it's all working by logging back in here. Great. And I create a new database every time, actually, which is really inefficient, but there we go. It does make the demo more likely to succeed. So there's our new process. So let's first of all take a look at how the effect this initially has, and it's quite a powerful one. So let's just get rid of that. Let's send Pond wants some cake and coffee again, and that's it. So now I will also order something, maybe just some coffee. Great, and then, oh look, we have our cake is ready. There's the first thing that's kind of different. You can see up there, it says cake is ready. Oh, and a coffee has come back for Pond as well. So the thing we have that is quite nice is a correlation key. In Starbucks, the correlation key they use is the name, oh well, not your name, but whatever name they decide they've heard, and that's what you get in order to get your coffee back. And so we're using the same thing. So we can have a correlation key that maintains the transaction across multiple services, and then we can return back. And you can see here that the first change is that the cake came back independently of the coffee, because now that we're holding state, we can actually do these things sort of in parallel, which is quite nice. Because if we couldn't really do that before in parallel, because if the coffee failed, what would we do? We would then take half the person's money? Would we have to tell the cashier to give them back stuff? It's way too complicated. But this way, we actually can give the responsibility to the order sorter to deal with this and to hold the state during that. So now let's have some fun with our barista again. Bye. So let's order a coffee. Great. Let's say Pond also wants a coffee and cake, and so does Martha. Okay, great. The cake is coming back quite quickly. Doesn't take too long to get cake, apparently. And that is all going very, very well because the order sorter can basically deal with that themselves. The problem we're having, and we know this problem exists, is that the barista is gone, so we cannot do any of this coffee stuff. So how does the order sorter deal with that? Let's take a look at what's happening. So this is how it deals with it. It has basically got it's got the state. So it knows what's going on here. You can see, like, if I pick one of these, I can see, okay, well, I have the order because I have all the variables that were sent in, which is great. And this thing has a problem, so let's take a look. If I look at the incidents, and it gives me a stack trace of what actually happened when I tried to make the order. And it's clear that there's something not quite good. The front end doesn't actually know anything about this yet. The front end's kind of relying on the order sorter to deal with this. And so we, as the admins of this particular service, now need to deal with the fact that we have these three. Step one, we need to wake up the barista again. Okay, the barista's awake. Now this doesn't help us because the orders are still stuck in an error state. So we actually need to just tell let's go to the processes. These are the processes that have instances. I'm just going to execute an operation on them all. We're going to tell them all to retry. Okay. There we go. So set retries to 1 for all these failed jobs, and that's going to mean that they're going to just try again. Okay, that's done. And now we should see our barista is now making coffee again. Okay, because as soon as we try to retry, it figured out the barista is alive and well, and that is all going very, very well. Okay, so we're in pretty good shape so far. But there are still problems with this. The first problem is, First of all, I have been sitting here waiting for my coffee for quite some time. You can see here, and that is not a good experience. We actually would much rather have the order sorter understand that even though it's asynchronous, it shouldn't last forever. There should be some kind of way to tell the service that you've asked, don't worry, we're still working on it. Or at the very least, reassure customers that we'll get to there eventually. The other thing that's quite nice to do would be to not have to deal with the fact that our barista constantly falls asleep by having to go into some UI and add a bunch of retries. That's a nice method for one-off things, but the barista actually seems to fall apart fairly frequently. So we would actually like to prepare for that particular thing and maybe try and deal with it programmatically. Or, we could get a more reliable barista, but this is, I'm less confrontational. Just to have to deal with the fact that he's bad at his job or she's bad at her job. So let's take a look at what we can do next. The next one is one of the ones, again, I'm just changing the model now. The engine's already added, the first model already exists. The only thing that changes now is my ability to use some new functionality in the model. So this is the new one. Now, for anyone who doesn't know, this is BPMN 2.0. It is a business process model and notation. It's an open standard created by the OMG a while ago. There are lots of modelers, lots of engines that execute this. But at this point, what I wanted to tell you is that we are not dealing with a diagram here. We're not dealing with a picture of how things will be. This is directly executable. We've created something the engine legitimately reads. We are not creating something that is somehow transformed into something executable. It's transferable, it's open source, and open standards. So that's really important to know. So you can learn this independently. The thing I've added to this is in the bottom there, which is a really great feature of BPMN, and also an amazing feature if you ever try to deal with trying to code let's say, timers within services. What I've done is this little box here with the dotted lines around it is called an event subprocess. It basically is waiting for an event that might occur as long as this process is alive. Now, there's lots of types of events we could use. There's conditional events. So if you can wait for a specific condition to happen and then trigger this and then do a thing. And the nice thing is that can happen independently of the rest of the service. So you could actually, in this case, you can choose it to be interrupting or non-interrupting by the full circle is interrupting and then the dashed one is non-interrupting, which means it'll just happen in parallel. Now what you're looking at here is a non-interrupting timer event. And it says here PT30S, which is ISO 8601. I'm sure you all knew that already, which is a time standard for durations. And it is saying that as long as this process instance is alive for 30 seconds, that is too long as far as we're concerned. And so we're actually going to trigger to tell the cashier about the delay. That's basically how we're going to do that. And meanwhile, what's going on here is not affected. That's the goal. The second thing I've done, which is going to solve our retry problem, is that this thing here, because we know that our little service could potentially fail, I've added a retry time cycle. So if it fails, this is, again, that lovely ISO standard that we just saw for the timer. It's basically, if it fails to reach the barista, I've told it to retry 4 times every minute. Now, we learned from the keynote this morning that, of course, it would be better if I had exponential backoff with some randomization in there. And I can do that, but I just hadn't thought that far ahead. So this will just be able to say, I failed once, but you do not need to deal with it. You don't need someone who's in charge of DevOps to come in and try anything and mess around and retry stuff. It'll just pick it back up in a minute and try again. And only after it's failed 4 times will it do that, which is super handy. So let us go and run that and see what happens. It's 3, I suppose. Okay, so 3 is up. And let's verify that again. Okay. So this is our new service. We can see it right there. There's a few different things we can do. So let's first look at what would happen if everything's working correctly. So coffee and cake, great. Let's see, Pond wants the same. Pond prefers soy milk, actually. So let's just make that happen, great. And this is all happening as we would expect, with all of our services doing their things quite rightly, and nothing too unexpected, and we can check the history there, and things have all run basically okay. If you want, you can actually see cool colors. Who doesn't like colors? So that shows the most common route through the process. So now let's try and trigger this right here. So for that, I, of course, need to, our reliably sleepy barista is going to fall asleep again, and I'm going to get some more coffee, great stuff. And so they're going to be doing their thing, great stuff. And meanwhile, we should be able to see that we have, our cake has been gotten, and we have 2 instances that are waiting right there. Now, they've already failed once at this stage, but you can see that no error has been raised because it's actually not an error yet. We're expecting this. We've modeled for this particular thing to happen. And so it's completely predictable. And this thing should eventually then trigger and tell us it's going to take a little longer. And the benefit of this, of course, is first of all to give the people waiting for their coffee just a much better feeling that things. So there we have your order is taking a little longer for Pond and for Niall because we have this correlation key, so we know exactly which ones are going to be taking longer. And so as soon as I start back up the barista, it's then going to, this thing here will then, the next minute is up, it'll actually just wake up, it'll pick that job up and try again, and it'll succeed on all likelihood, and then we'll get our coffee. So this is a very nice addition as well to how this works. And again, it just kind of requires changes to this model, which is completely visible visual. So it's a way of being able to completely see what's going on and be able to change things by simply adding symbols. It can get BPMN can do really complicated things, and I've kind of just built some kind of basic stuff here. So yes, we have our coffee in all likelihood. Oh, there we go. So they both got their coffee. So that all is a great success. So wonderful. Let's refresh this. So what could possibly be next? Well, the other nice things that we can actually do are kind of twofold. The first is deal with non-technical errors, which is really nice. There's an example of, in this case, the non-technical error we're going to deal with is this thing here, no soy milk. It's a real shame. So you can see here that we have an error boundary event on here. Now, this isn't for technical errors. This is a specific symbol that's designed to catch and deal with predictable business errors that we expect will happen over the course of this, that we maybe can't do anything about, or that we can try and fix, or in most cases, we can include a human. Very, very often, these things are completely are orchestrating completely automated services, and when they break, they don't necessarily, they can break in a predictable enough way that we can actually create a user task in which a human can then log in, see all the context details, and actually deal with that. So it's very often used like that. In this case, it's going to randomly decide whether we have soy milk or not, and then send a message back saying we don't. They still get their cake in this case, which is quite nice. Okay, so let's try and see if we can do that. Okay, number 4. And let's log back in. Now, there's one more very nice thing I can do, and I'll do it while I'm here, which is our barista is still asleep. And as opposed to having to deal with our barista randomly falling asleep all the time, another very cool thing we can do is we can actually predictably tell our barista, okay, let's tell you what, you can go to sleep now. Okay, you can just go have a nap. And what we'll do is we'll just save up all the orders as they come in. What I'm basically saying is we can plan for predictable downtime. So we can say we know the service is going to be down. We don't want to do the retry thing because it only lasts 4 minutes. Instead, we can say, okay, here's our service that we know is going to be down. So I can just say, okay, I would like, oops, let's go to the process. Yep, so there's our job, and I'm going to just pause it. Okay, so what does that mean? It means that whenever something gets that far, it'll just wait there. So if I send in a coffee order now, they're getting their cake, and let's see, who else? Okay, what we should see is we should see a whole bunch of coffees piled up here. And they can wait there because we're holding state. We know we have to make them, we know the barista is asleep, but we can have the scheduled downtime while the rest of the process runs completely correctly, which is really nice. So nothing else is affected because we're going through this particular route, which I like a lot. So if I wanted to restart it, I would just click play. Well, I won't do that until I start my barista back up because that's a bit unfair. So the barista goes back up. And then we can click play. And we can also do a delayed thing where we can say what time we would like to bring it back online, but let's just do it that way. Okay. Marvelous. So the barista then should eventually then start doing a bunch of coffee, I guess. There we go. So it's now picked that up now that they're awake, and it's a much easier and nicer way to deal with a difficult service that has potential to have different downtime, because in microservice architectures, you don't control every other service, and you have to plan for the fact that something is going to be down at some stage. People are going to tell you, yeah, we're bringing our thing down to upgrade it. This is now your problem, not really ours. So this can actually deal with that in a really nice way. It can also deal with it with unpredictable or less predictable failing. We can also do this retries, which is quite nice. So let's see how our history looks. Okay, bad news for people who like soy milk. So we now we have our order taking longer. You see that happen because the barista's on a break. And then following up from that, we had our no soy milk, sadly, for anybody there. So that was a real shame. And of course, that took this particular route of being triggered down here. It's really easy to trigger these things as well, and they can do whatever. So another thing I want to show off is the fact that, again, this is relatively unique, the fact that we have all this lovely data, but we have this data in a context. Now, if this thing has worked, what we can do is we can get that data, and we can check out what's going on and visualize it using reporting and stuff like that. So for instance, if I wanted to find out, let's just find out like just some quick reports on stuff. So this is my order process. Let's just take a look at what we can find out about it. So here is, we saw this already, this is the most common route through the process. So it's pretty okay, 4 times that. So, but let's also check out the duration. So this actually shows us where we spend most of our time. And that's super handy, because this, if you have it across lots of services, can let you know which are the reliable services. But you can do that, but in the context of the process you've built, it's a really powerful thing to see, because everyone already knows this is how things work. We have built this process, we understand it, and now we can overlay data on it, which is really nice. This is very quick. We can also do other things that are not just process-related reporting. So for instance, maybe I want to, I don't know, a bar chart, but I want to find out about which orders come in the most. So this is how long the average process instance takes, by 52 seconds. We can, maybe let's look at some flow nodes. We don't want them all. Let's just look at the ones that we care about. So I don't really care about all of these. I just really care about this one, this one, this one, maybe this one, and then add that. And tables aren't very pretty, so let's use a bar chart. Okay, so then we can sort of get that data and then visualize it in a way that lets us know that we have a lot of, let's actually go with instance count instead. There we go. That we have exactly the same number of people ordering cake as they are ordering coffee, and we also have the soy milk thing. And the nice thing about these reports is that they're live because they're getting all that data as your service runs. So let's just add a bunch of this to skew the report a bit. Okay, so let's save this as something bar chart. Good name. Okay. Okay, wonderful. And now we can, the nice thing about it is that this bar chart is, it's already changed because, of course, I've sent a bunch more instances through. So this is like a live sort of indicator of what's happening in your processes, but also a live indicator we've added to one microservice that tells us a lot about the barista, for instance, about how long they're taking. We don't need to add something there for that. That's actually quite a nice benefit of adding that. So we added initially our visualization history by adding the engine. We got visualization when we just added the engine. We didn't actually add at that point any of the state handling. We just added the engine and kept it synchronous, and we still benefited from visualization. The other things that we added as we went along is we added some retry mechanisms. We added some timeouts. We added a callback to the cashier, which is really important. We have versioning, error handling, and history. We only changed that one service in the middle, which is really nice. It wasn't a huge architectural upheaval, although there definitely needs to be some changes. Were I to go on a little longer, I'd probably talk about idempotency, of course, which is, again, easy to implement. It's not hard to implement idempotency once you're holding state, because you can then check what's come in and then say, we have that one already. But that will be a really important thing as well to add. The stuff here that I demonstrated is all on GitHub for those interested, of downloading, giving it a shot. The stuff is all open source to play with. So if you'd like to add some state to your microservices, go ahead. I think a nice place to start, if you want to build a quick Spring Boot microservice that already has the engine in it, basically it's a glorified copy and paste into a POM file, but still it's kind of useful, you can go to start.camunda.com if you want to play around with it. That'll generate the web apps and everything else in a Spring Boot application. So it's a good getting started point if you want to play around with that. So I think that is all. I'm going to, if anyone has any questions, I'll take them in a little while, but until then, thanks very much. That's all I got to say.